Right, so now we're looking at integration question from a past paper. This is 2019. So we're going to use the principles that we've learned from integration by recognition, integration by substitution, integration by partial fraction, and integration by parts. So this question is an integration by parts question where we have to remember how by parts go is the integral of u dv, the integral of u dv, integral of u dv is equal to uv, integral of u dv is equal to uv, u times v minus the integral of v du. All right, so that's by parts formula. That's what we're going to use. All right. Now, in this case, we're going to call ln x to the n u, and then we're dosing another function. So that means the dv must just be 1. Makes sense, don't it? So what we're then, now, what I want to point out now is we're calling our u ln x raised to the nth power. And so what we're pretty much saying is that our dv has to be 1. Think about it. We're integrating ln x to the n, which is this. So your dv has to be 1. dv is equal to 1. So now when we differentiate ln x, we're going to get du is equal to, we carry down the power n, we subtract 1 from the power to get ln x to the n minus 1, and then we multiply it by what's inside the bracket. What's inside the bracket is the differential of ln x is 1 over x, so that's du. To get v, we need to integrate 1. When we integrate 1, we are just getting x, and so that's what we're getting. All right, very easy. So now let's shell down the rest of this question now. So now what we're saying is the integral of u dv, the integral of u dv now. So the integral of u dv, this is u dv. So the integral of ln x raised to the nth power, the integral of u dv dx, it's equal to u times v. Now here is u and here is v. So it's equal to u times v, so it's equal to x multiplied over u, and our u originally is ln x raised to the n. All right, so it's that minus the integral of v du. Now this is what I want you to observe, v du. Now x times 1 over x, the 1 over x gone. Can you see that? X times 1 over x, the x gone. And so it works out to be the integral of n times ln x to the n minus 1. So it's ln x to the n minus 1. All right, and that's that question. Of course, we put a dx. And so all of this initially, we can just call it fnx. So this initially is just fnx. So what we get is fnx is equal to x ln x raised to the nth power, ln x raised to the nth power, minus, we can factor out our n, we can factor out the n, and we'll get n times the integral of ln x raised to the n minus 1, and the integral of ln x raised to the n minus 1 is fn minus 1. All right, now look, fnx is ln x to the n. So if we replace n with n minus 1, then ln x to the n minus 1, the integral of that must be fn minus 1. This is fn minus 1 of x. All right. An easier way to see it would be, what if I were to factorize out n right here? So instead of putting the n right there, I'm going to put it outside of the integral bracket. I'm going to put it in black right here and write it as minus n times the integral of this. And the integral of this is fn minus 1 of x. So we've shown that. Very easy, soft. Very easy question. So we've shown that. And that's how many marks? That's 3 marks. This is CAPE 2019. 3